So let's take a little deeper dive into MAC addresses and what MAC addresses look like. So this is not meant to be an exhaustive look into MAC addresses, but we're going to take a look at MAC addresses and how MAC addresses communicate, what it looks like. Then we'll get into a unicast and what a unicast looks like, what a broadcast looks like, and finally we'll finish up with multicast and what a multicast address looks like. So a MAC address is 6 octets long. Here are a few different examples of that. And as a frame gets built and sent out of the network interface card, then it will add the source and destination MAC address. It'll actually add the MAC address first to the frame, the destination MAC address, then it'll add the source MAC address. This is because a switch, the most prevalent information it needs to know is where is the destination, where is it heading to? So that way it can send information on as fast as it can to its destination. And so that's where a frame gets sent out and sent to the destination MAC address. And that's how communication happens on an Ethernet LAN. So what does a MAC address look like? Well, it is ones and zeros. We know that the language of a computer is ones and zeros. So this is just the starting of what a MAC address could look like. Now, if we were to relay hexadecimal numbers in their binary form, it would be a little hard to relay that information with a series of zeros and ones from one person to the next. And so really, we actually relay MAC address or represent MAC addresses in hexadecimal form. It's just a way for us to more concisely relay that information. And so to do that, we have to break things into more of a hexadecimal form. And hexadecimal is represented in 4 bits, not 8 bits. So typically what we see is things represented in bytes or 256 possibilities, but hexadecimal is in 4 bits rather than 8 bits, and it's represented in numbers 0 through 9 and A, B, C, D, and E, and F. And so I've got here a table of how to translate from binary is the first column, the second column is decimal form, and the third column is hexadecimal. So, and hexadecimal goes anywhere from 0 to 15. So there's 16 possibilities with 4 bits. So what I'm going to do is I'm going to show you how we translate from that binary number to a hexadecimal form. So I've got the binary numbers written here at the top. We've got to break that down into 4 bits and 4 bits and 4 bits. So you can see here along my next column here, I've got that broken down. And then each one of these, I need to then translate that into what the hexadecimal value is for those. So here I've got 1111. I look this up in my table and that's an F. I look at the next one, 1110. I look that up in my table and that's an E. My next one is 1101. Look that up in my table and that's a D. Then I've got 1100. I look that up in my table and that's a C. And I can continue to translate this. You probably see a pattern that's developing here. I've got 1010 and that's an A. I got 0101. So I looked that up. Oh, broke my pattern here. That's a 5. I got 0100. That's a 4. And so you can see I'll finish this off. And there we go. So now I've got my hexadecimal numbers down here on my last row. So the way this is then portrayed is we have a 01-23-45-AB-CD-EF. So this is commonly the way a MAC address is displayed. So these MAC addresses are broken into 2 parts. The first part is what's known as the Organizational Unique Identifier. The OUI is what is assigned to specific vendors. So let's say you are a vendor, you are a manufacturer, you develop and send out some sort of device that has a network interface card on there that requires a MAC address. So you would go and register and get a number, a 3-octet number that would be designated for you. So it's the organization. And then what you do is you have the second 3 octets to work with, and you would assign those to all of the hardware. And it would be your responsibility to make sure that you don't assign the same hardware, you don't assign 2 different pieces of hardware the same MAC address. Because remember, MAC addresses are burned into the equipment. So if you had 2 different devices with the same MAC address on the same network, it would cause some functionality issues. And so these need to be unique. And so it puts the hands of making sure this happens into the hands of the manufacturer. So then when you run out, then you would go back to that organization and you would ask for another OUI, so that way you can continue manufacturing your equipment. And the second of this series here is just called the Universally Administered Address, or the UAA. So the first part is the OUI, the second part is the UAA. Now, Unicast happens just as what we mentioned before. There is a destination MAC address that gets added to the frame as it's sent out the network interface card, and it has a source MAC address as it's sent out, and it gets from one location to the next because the switch recognizes what destination MAC address it's going to, and then forwards it out the port to get it to that device that owns that MAC address. Now, a broadcast is a message that's going to be sent, and the switch will actually broadcast that out all live ports. And so a broadcast could be, well, an example of a broadcast may be an ARP request. We know that if we have an IP address of a server, but need the MAC address of the server so we can send it information across this LAN, we need to do an address resolution. So we use the address resolution protocol, we send it out, that request goes out all ports, this machine gets it and sends back the response with an IP address, or excuse me, with a MAC address. So that IP address, so this machine can turn that IP address into a MAC address and send it out. But the problem is it doesn't know the destination where that's going to go to. And so what it does is it sends out the ARP request, but he sends it out with an address, a destination address of FF, 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 FF. And so that series of all ones, essentially, if you look underneath it there, that series of FFs that get sent out lets the switch know this is going to be a broadcast, and then that switch will broadcast it out. So this is a broadcast, and everything that happens within this local area network, we call that, because anything that is sent to this address right here, we call that a broadcast domain. So everything within this layer 2 here is a broadcast domain. So a multicast frame is used to send data to specific clients. So it's a one-to-many. So let's say this machine wants to send to a couple different clients on the network at the same time. It can use a multicast. It could use multicast frame to do that. So as it sends it out to the switch recognizes that it's a multicast, and then will send it out those ports only to those machines. Of course, this switch does need to know which ports to send based on that multicast address. And so it will do that in several different ways. You can either program the switch to do multicast on certain ports, and so that switch knows which ports to send it out. Or there are some dynamic ways for this switch to learn and make sure that these devices check in or subscribe to that multicast address. So when that address comes in when that frame comes in with that destination MAC address, it can get that to those machines. Okay, let's take a look at the multicast MAC address, which is what I have right here. So a multicast MAC address starts out with 01005E. So this first section signals that this is a multicast address and to be treated as such. In fact, I've actually got it broken down a little bit further here. So you can see the hexadecimal number. You can also see the binary numbers that are associated with that. And the reason why I broke it down this way is for two reasons. Number one is because I want to point out that this 0 is always a 0 right there as well. So you've got the first bits, the first half of this really, which is always the same for multicast address, and this first bit of the second half is always 0. The other reason why I want to point this out is because there is an association with the IP address of a multicast address and the MAC address of a multicast address. And that is the IP address has some bits that are similar to it. The first bits are not. The second set of bits, the first one is not, because I have already said that's always a 0. But the last 23 bits is the same, and it's a direct one-for-one with the MAC address. So if there is an IP address associated with the MAC address, then we'll see this association of the last 23 bits that are associated with the last 23 bits of a MAC address, a multicast MAC address. So let's finish up talking about MAC addresses. We talked about MAC addresses and what those look like. We talked about unicast and how unicast happens. Broadcast, we took a look at the broadcast address, and multicast, what a multicast MAC address looks like. I hope these videos are really helping you out. If they are, I'd really appreciate you hitting that like button.